Okay, guys, so sorry about that. Connor called. Then I did this problem and he called again. So hopefully he's done for the night. All right, for 26 through 38, they're all solving problems. So you are going to have an answer of x equals some number, okay? Could be a number, could be a radical, could be whatever. Now, this here, we don't have any radicals, okay? This is a quadratic, meaning it's a parabola, it's an x squared. You have four ways to solve it. You can factor it, maybe. That's the first thing I look for. Square root property, but you couldn't on this one because you can't have that middle term, so that's out. You could complete the square or use quadratic formula, but in order to get the correct answer, you have to use the formula correct. Okay, so the first thing I don't like is I don't like my x squared being negative. So I could move everything over to the other side and that would do the trick. I could factor out a -1. That would make, I could just change, that would do, factor out a -1, then divide everything by -1. Or I could just change the signs. If I change this one to a positive, I have to change this to a positive 2x, and I have to change this sign to a -63. And I would change the sign, but it's 0, and 0 is neither positive or negative. I can do that because I could multiply both sides by a -1. You can do whatever you want to both sides, as long as you do it to both sides. What you do to one side, you do to the other. So if I multiply by a -1, this is what I would end up with. Okay, now I am going to factor this. Okay, it is going to factor as x plus 9, x minus 7. Now, I'm going to do this one more time, and this will be the last time I do this. If you want to do the box method, that's perfectly fine. I'm not complaining about it. If I can factor without it, I'm going to do the fastest thing. So what I'm going to do is I'm going to take my a, which is 1, multiply it by my c, which is -63, and I get -63. Then I have to pick numbers that multiply to give you that -63, that add to give you 2. So that would be 9 times -7. When I add that, I get a +2. Okay, so then we do our box, make our box. And thank you, Cole, for teaching me this, because I will teach it from here on out. I'm going to put my x squared here. I'm going to put my -63 here. In these two boxes is what I'm going to replace with the 9x and the -7x. And I don't care which one goes where. Okay, I'm just going to put it there. All right, so now I am going to factor by rows first. I can factor out an x. And here I can factor out a -7. Because this is negative, I'm going to factor out a -7. So that's where I get the x minus 7 from. Right here, I'm now going to do the columns. So this column here, I can factor out an x. And then this column here, I can factor out a 9. It's a +9. If this had been negative, I would have factored out a -9, but it wasn't. So x plus 9, x minus 7 equals 0. Now, at this point, what you do is you set each factor equal to 0. So I'm going to subtract 9, and I get x is equal to -9 right there. Here, I'm going to add 7, and I get x is equal to 7. And those are my two answers. Notice I have x equals 2 numbers. Now, you can check your answers by using your store button. I am going to take -9. I'm going to use my store button, which is right here, the STO button, and I'm going to store it under my x. Now, when I use my original problem, 63 minus 2x minus x squared, when I hit enter, it should give me 0. Otherwise, it's wrong. So now I'm going to say 7 store x, because I can check them both, and I can also get 0. Okay, 27. Now I'm going to work these all different ways. Doesn't mean that you had to do it this way, okay? For 27, you get x squared minus 18 equals 0 is how the problem reads, okay? Now, if you want to, this will not factor. If you want to, you could use quadratic formula. I'm not going to because I'm going to do it the fastest way. I have a lot of problems I have to work, so I'm going to do it the fastest way. I'm going to take the 18 over to the other side by adding it. And that gives me x squared equals 18. Now I'm going to take square root property. Don't forget, if you're going to use the square root property, this is going to give me a positive and negative square root of 18. But I can simplify that. It's really 9 times 2. There's a perfect square in there. Square root of 9 is 3. This, again, going back to what I did before, this is like saying the square root of 9 times the square root of 2. So I'm going to get a positive and negative 3 times the square root of 2. Now, I can even check this one. Watch. 3 square root of 2. Okay. I'm going to store that under my x. Let me clear this. Okay. And then I'm going to type in x squared minus 18. And if it's right, it should give me 0. There you go. Sorry about the glare. I've got a light on because it's dark in here otherwise. And I can also check the negative 3 square root of 2. Store that under x. Bring that back up. And I still get 0. All right, 28. Now 28 looks like this. Two x squared plus 5x minus 1 is equal to 0. Okay, I was just looking at any of these problems because I was going to try to do one by completing the square, but other than this one, there isn't one. So, I mean, that I would use it. I was going to do it on this one, but in order for me to complete the square, I have to divide everything by 2, which gives me a fraction here because you have to have an x squared. So, all right, and you probably aren't going to use that anyway. You're probably going to use quadratic. This will not factor. You can't use the square root property because you have a middle term right here. I wouldn't complete the square because of that 2. It has to be an x squared. So let's go with quadratic formula. So opposite of b, so that's going to be negative b, which is negative 5. Plus or minus, don't forget about that. B squared, so it is 5 to the second power, minus 4 times my a, which is 2, times my c, which is negative 1. All over 2 times my a, which is 2. Okay, I'm going to go ahead and find my discriminant first before doing anything else. 5 squared minus, which is 25, minus 4 times 2 times negative 1. That gives me 33, and that's because this gives me 25, positive 8, which gives me 33. That will not simplify. All over 4, 2 times 5, 2 is 4. And we're done. The only thing you would have to do, I don't know why I didn't box my X in there. The only thing I didn't do is if the answers were exact, which is probably going to look like this, but if they were all decimals, then you would have to change this to a decimal. Now be careful. If I were you and you have one of the newer calculators that has this F1, okay, the alpha y equals, and you can do this, I would use this for the final. I'm just really lazy about it because I don't like to use it. Just make sure you have this, okay? So it would give us whatever the decimal is to place, you know, like if it, I don't know, you'd have to look at your answers. If it rounded 2 decimal places, it'd be 0.19, okay? And then the other one, you just go and you change it to a subtraction sign. Oops, let's change it to a minus sign. There we go. And there's the other one. Okay, I'm guessing that your answer is going to be like this. Now, the other thing is if you do not have that fraction key, because some of you do not, I'm trying to get this so that it's not all glare. There we go. Okay. If you're going to do this in your calculator all at once, this whole thing has to be in parentheses. Okay. I always just do it in 2 steps, but if you were going to do it in 1 step, this is what you'd have. Make sure you use the right arrow key and then divide by 4. When I say I do it in 2 steps, it's because I do this. -5 plus second square root of 33. I get my answer, divide that by 4. Same thing, those 2 answers. Okay, 29. You need that now. That was just to show you. I don't know why I'm bothering with it. All right, number 29. It looks like this. 2x plus x minus 1 equals 0. Okay. This will factor, so I'm going to factor it because I'm just, oops, let's try this. 2x squared. There we go. Because I want to do it the fastest way I know how. The only way to get 2x squared is 2x and x. One has to be plus, one has to be minus. Be careful, the plus 1 goes here, and the minus 1 goes here. I don't care how you do this. If you want to use the box method, feel free, you'll get the same thing. I just do it trial and error. Positive 2x, negative 1x gives me that positive x. Now, what I have to do is I have to take each one of these factors and set it equal to 0. So I'm going to move that over by adding 1. Take the 1 over there. So I get 2x is equal to 1 divided by 2, and x equals 1/2. Right here, I'm going to subtract 1, and x equals a -1. So there's my 2 answers. And then you can check them if you want. We'll just go with it, okay? Number 30. Now, I'm going to do this the fastest way. When you look at my notes, I used quadratic formula. So this way you get 2 different ways of working the same problem. Okay, on this problem right here, to get rid of that square, I'm going to take the square root. Okay? That means this and this is going to cancel each other out. So I am just left with x plus 7 equals. Over here, though, okay? Over here, I am going to end up with I times the square root of 5, plus or minus, okay? Plus or minus, I gotta be real careful. plus or minus I times the square root of 5. Why is that? That's because I can rewrite that as negative 1 times 5. The square root of a negative 1 is I. Okay, and again, we put that square root in there, so it's got to be plus or minus. Now I'm going to subtract 7. That cancels out. I like my plus or minus to come second, so I write it as negative 7 plus or minus I times the square root of 5. Okay. Now, if you put the minus 7 last, that's fine. Now, what I want to show you is when you go to look at the answers, okay, look how I worked this problem. I worked it the long way, all right? I squared this to get this. Then I subtracted 5 to get that, okay? This won't factor, so I had to use quadratic formula, but I still ended up with the same answer. This was a lot longer than this. And here I didn't have to reduce. When I used quadratic, I had to reduce everything by 2. So, but it worked either way. All right, 31 looks like this. Two x squared plus 3x equals 20. Okay, so what I'm going to do is, in order, because this is quadratic, you've got to take the 20 to the other side. Okay, so when you do this, you're going to end up with 2x squared plus 3x minus 20 equals 0. All right, this factors is 2x and x. That's the only way I can get 2x squared. This is going to say the signs are different. I could say 1 and 20, 2 and 10, and 4 and 5. I'm going to do 4 and 5. I'm going to put the 4 here and the 5 here, plus and minus. And I'm going to show you the box method on this, even though I said I wasn't going to do it again. Apparently, I wasn't telling the truth. 8x negative 5x gives me 3x. Okay, but if you were going to do the box method, AC would be 2 times the negative 20, and that's going to give me negative 40. Okay, so multiply to give me negative 40, add to give me that 3x. Well, really just 3. Okay. I mean, you can do your x's. It doesn't really matter. I don't care. Okay. So I know I can have, it doesn't matter what signs, you know, one's going to be positive, one's going to be negative. Because it needs to be a positive, I'm going to make my number, my bigger number, the positive one. Because see, now when I add that, I get 39, a positive number. Okay. And you could get negative 2 and 20. That's going to give you 18. Negative 4 and 10. That's going to give us 6. And I'm drawing a blank right now. And then I'm just going to get negative 5 and 8. I got lost on what I was doing. And I get 3. And that's what I wanted. Okay. Because again, I am trying to factor 2x squared plus 3x minus 20. Okay. That's what I'm factoring. Okay. Oh, goodness. Where did I get the 30 from? I said 3x, but I wrote 30. 3x minus 20. See, that's what I had right here. Okay. All right, so I did this. Now I'm going to do my box. Two x squared goes here. My negative 20 goes here. Now, I needed the 2 factors I add to give you this, and they were that. So I don't care where you put what number, it doesn't matter. I'm just going to put negative 5x on right here. I should have made my box a little bit bigger, but negative 5x, positive 8x. Okay, now I'm going to factor by rows and then by columns. They both have an x in them. Factor out an x. I can factor out a 4. And that's a positive 4, so I have x plus 4. Then I'm going to do columns. Okay, I can factor out a 2x here. And then when I factor out here, I can factor out a negative 5. See how the negative's on top? So it needs to be a negative 5. 2x minus 5, that's this one right here. And x plus 4. That's a plus sign, you can't really see it. Okay, and that's how it factors. Okay, now that it factors, you say 2x minus 5 equals 0, and x plus 4 equals 0. Add 5. I get 2x equals 5. Divide by 2. And you get x equals 5 halves. If you want to, you can have 2.5. Just like here, you could have had 0.5. Really have to look at multiple choice answers. This is fine. It's okay to put 2.5 because those are equal. Minus 4. And you get x equals negative 4. And you can check your answers just like we did before. The only ones you can't check are these here. Okay, 32. All right, 32. Five x squared plus 4 equals 11. Well, seeing I have no middle term, I do not have the bx, it's only ax in our constant. Okay, we don't have that middle term. I'm going to use the square root property. So I'm going to subtract 4. This is 11. That arrow now has kind of messed it up. So I now have 5x squared equals 7. Now, I can't take the square root yet until I get my x squared by itself. So I'm going to divide by 5. And I get x squared equals 7/5. Now I'm going to take the square root of both sides. All right. Now, you get x equals. This here is the same thing as saying plus or minus the square root of 7 divided by the square root of 5. Well, we know we can't have our answer with a radical in the denominator. So we are going to multiply both the top and the bottom by the square root of 5. This is called rationalizing the denominator. So we now get plus or minus, don't forget positive or negative, square root of 7 times the square root of 5 is the square root of 35 on the top. On the bottom, square root of 5 times the square root of 5 gives the square root of 25, which is 5. And that's our answer. Guys, these will not reduce to give you 7. Can't do that. The only way you can do that is if it was the square root of 35 divided by the square root of 5, but it's not. Okay, so that's our answer. 33. I think 33, I'm going to need more room than what's up there. I'll try and squeeze it in there. 33 looks like this. 4x squared minus 6x minus 5 equals 0. Okay, unfortunately, it does not factor. Okay, so that means I'm going to have to use quadratic formula. Yeah, quadratic formula. So, because this isn't an x squared. So x equals negative b, so that gives us a positive 6, plus or minus the square root, negative 6 squared, which is 36, minus 4 times my a, which is 4, times my c, which is negative 5, all over 2 times my a, which is 4. Now I'm going to get 6 plus or minus. Okay, when you do this, this gives us 36. This here is going to give us 80. So 36 plus 80 is going to give us 116. But you don't have to know that, okay? Your calculator is going to do that for you. Just be careful when you're finding this number that's called the discriminant, okay? The discriminant, make sure you rather leave this negative out because it's going to give us a positive when we square it, okay? Or make sure all negative numbers are in parentheses, okay? See how I did that? That's going to give us a positive 36. Minus 4 times a negative 5, and you get 116. All over 8. Now, what you have to make sure is there a perfect square that goes in here? So we're going to go to y equals, we're going to do 116 divided by x. Go to our table, hitting second graph, and 4 and 29. I always look for 4 first, okay? 29 cannot be split up, okay? So I know that's the largest one. All right, so I can rewrite this here as the square root of 4 times the square root of 29. Well, the square root of 4 is 2 times the square root of 29. So this really is 6 plus or minus 2 times the square root of 29 all over 8. Now here's the problem. It is correct, but it's not reduced. I can reduce all of these by 2. I can divide this by 2, this by 2, and this by 2. Everything. This becomes a 3. That gives us a 1. This gives us 4. So we have 3 plus or minus, I don't need the 1 out there, square root of 29 all over 4. That's my x values. You could even check these, okay? I think I may have shown it to you on another problem, but I'm going to show it to you again. I'm going to say 3. Well, let's do it how I would. Well, I'm going to do this. 3 plus the square root of 29. I have to make sure that whole top is in parentheses. I can use the fraction key. It's okay. Divided by 4. I get this number. I'm going to store that under x. Now, I'm going to plug that. I'm going to plug this in, and it should give me 0. 4x squared minus 6x minus 5. Okay, it gave it to me in scientific notation. This was probably a bad thing to show you guys. But it's okay. This number here, that gives me a number that looks like this. Negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that is that number. That is so close to 0. The reason it won't give us 0 is because your calculator is actually rounding this irrational number. Okay, I guarantee you when I change this to a minus sign, I'm going to get something that's close. It's not going to give me that 0. Hold on, I'm going to bring this back up so I don't have to do everything all over again. Okay, I don't know why I'm just going to store that under x. Now I'm going to bring the other one up. And it did give me 0 that way. Let me see if I do it the other way, where, because I changed it to a decimal, but what if I did it like this, where I took this with a plus and went straight to X, okay? Now bring that back up. Let's see what happens. Nope, it still gives me that. It's just that number. The other one gave me 0, so not that you'll probably check it anyway. All right, 34. This was from chapter 7. We have 3 over b minus 2 minus 1 over b minus 1 equals 0. Okay, this is still solve. That means in this case, we need b equals some number, okay? Now, I can tell you right now, whatever we end up with, b cannot equal 2 here and cannot equal 1 here. Because if it equals 2, that makes that 0, and we can't divide by 0. If we have 1, it makes this one 1. So we can't do that either. So that's a no-no. All right. To solve this, you find your least common denominator, which means you write down the first one. Then you go to your second one, and we have to list that one as well because we don't have one there. Okay. So now what you have to do is you have to multiply both of these by your LCD. You want to multiply by your LCD. Okay. Now I did it a little differently on my answers because way back when I did it the way I do it, but now I kind of show it like this. You're going to say 3. I'm going to list these over here. Okay, list that one. I'm going to list this one. Okay, so what I'm going to do is I'm taking both of these and listing them. I'm going to multiply both of them by this. B minus 1, B minus 2 times B minus 1 over 1. Okay, multiply this times B minus 2 times B minus 1 all over 1. These cancel. I am left with 3 times b minus 1. Okay. Right here, my b minus 1's cancel. 1 times b minus 2 is b minus 2. So now, I come back over here, and I say, this here is 3b minus 3 minus, be careful, anytime you have subtraction, be careful, minus this whole thing, b minus 2, equals 0. Now, guys, I multiply. I also should multiply. I shouldn't have said that because that was 0, right? Yeah, because sometimes you have a number over here. You also have to say 0 times b minus 2 times b minus 1. You've got to multiply everything by that. But 0 times anything just gives me 0. Okay, so I still have 0 over there. I kind of was figuring you guys understood that, but sometimes that number here, you might have a 5. So you'd have to say 5 times that. Okay, now we're going to, this stays the same, but you're going to distribute, or you have a subtraction sign, so everything changes after that, just like in those other problems. This becomes negative, that becomes positive, equals 0. 3b minus b gives me 2b. Negative 3 and positive 2 gives me negative 1 equals 0. I am going to add 1 to both sides. So I get 2b equals 1. Divide by 2. And b equals 1/2. Okay, you can even check this if you wanted to. Okay, just going to show it to you real quick. 1 divided by 2, store x is going to change it to a decimal. Okay, I'm going to clear all this out. So now I'm going to use my fraction key just so it's easier. Alpha F1, just so it's easier for you to see. I'm going to have 3 on the top. I'm going to put x minus 2. I just changed my b's to x's. Okay. 1, and then I have 1 over. Oh, there was something I forgot to see. X minus 1. Okay, so what I did was I just changed all these to x's. Now, remember, this answer is okay because the only 2 numbers it couldn't be was 1 and 2. Always check that. But if you check your answer, it should give us 0. If it gives us some kind of mistake like it says divide by 0, that means it was one of those, but it didn't. So notice it came out to be 0. Okay, 35. All right, 35 looks like this. X squared, no, x over x squared minus 49 plus 7 over x minus 7 equals 1 over x plus 7. Okay, the numbers that, by the way, this factors is x plus 7, x minus 7. Okay. When you solve, x cannot equal a positive 7 or a negative 7. Okay, because if it does, one of these will give, or both of them will give us 0. Okay, or 1 or 2 of them. Okay, so you find your least common denominator. Write down the first one. Okay. Do we already have an x minus 7? Yeah, we don't need another one. Do we have an x plus 7? Yes, we don't need another one. Okay, so you're going to take each of these and multiply it by that. So we're going to have x over, I'm going to write the factored form. I'm just going to list them over here. List this, then I'm going to list this one. 7 over x minus 7, and then I'm going to list 1 over x plus 7. So what you do is whenever you have denominators, we don't want to work with denominators, and we do this a lot in our other class. We never work with denominators because we get rid of them. How do you get rid of them? Is you multiply by the least common denominator. Okay. To everything. What you do to one, you got to do to all. Hand's getting sore. X plus 7, x minus 7, all over 1. Okay. So when we do this, those cancel, I'm left with x. Right here, my x minus 7's cancel. So I have 7 times this x plus 7, which gives me 7x plus 49. Here, my x plus 7's cancel, so I have 1 times x minus 7, which is x minus 7. So here's what I get. When I multiply this by my LCD, I got x. Have a plus sign. This gave me that 7x plus 49. And this gave me 7 minus x. Okay. So now over here, I'm going to get 8x plus 49 equals x minus 7. Okay. I'm going to take this x over here by subtracting it. I'm also going to take the 49 over here at the same time by subtracting it. That's going to cancel, and so does that. So on this side, I have 7x. On this side, I have a negative 42. Divided by 7. Uh-oh, wait a second. Oh, this is a negative, isn't it? I was reading that as a positive. I couldn't see it with that. This is going to give me a negative 56. Okay, negative 56. And then that gives us a negative 8. Okay. $36. Yeah. X minus 2 over x plus 3 equals x plus 1 over x plus 8. Okay, again, we have fractions. We don't like it. Let's get rid of them then, okay? So, before we forget, I always am bad about this, but x cannot equal negative 3, and x cannot equal negative 8. Okay, let's check in something on the last one. All right, LCD, write down the first one, x plus 3. Then you go to your second one. We don't have it. We have to list it as well. Now you take both of your fractions and you multiply by them. Take this. Okay, and you multiply by your LCD. And you're going to get rid of that denominator. You're not going to have that fraction anymore. Nobody wants to work with fractions if they don't have to. Okay. That is going to cancel. So now, right here, we have x minus 2 times x plus 8. My 8, x plus 8's cancel. So here I'm left with x plus 1 times x plus 3. Okay, so when I multiplied that, I got x minus 2 times x plus 8 equals x plus 1 times x plus 3. Okay, I'm going to multiply this using FOIL. When you do that and you combine your like terms, you're going to get x squared plus 6x minus 16. You can do each step out, but I'm not going to work it out. Okay, 8x plus negative 2x gives us 6x. Right here, x squared, 3x plus 1x is 4x, and 1 times 3 is 3. Okay, I've got to get all my letters to one side, all my number. Actually, watch what happens. I'm going to take this over here, so I'm going to subtract it. Okay, that makes that, and that disappears. So now all I have is my x's and my numbers. Okay, so at this point, I have 6x minus 16, and I have 4x plus 3. So I'm going to take this 4x to this side by subtracting it. And I'm going to take the 16 over here. I'm doing this all on the same step by adding it. That's going to cancel that out. This is going to cancel that out. On this left side, I have 2x. Okay. Over here, 3 plus 16 gives us 19. Divide by 2. x is equal to 19 halves. Or it'll be 18.5, just depending on, I'm sorry, 8.5. Let's try 9.5. I can't get that straight. I've been working on these for, well, you know, because you will have watched it. This one here is 45 minutes long already, and that wasn't even counting the first one. Okay, two more of the solving. 37 looks like this. The square root of 2x plus 3 equals 5. And I'm going to go ahead and write 38 down, which looks like this. Square root of 5x plus 1 equals x plus 1. Okay. All right. First thing you have to do when you have radicals is you have to isolate them if they're not already. What isolating means, they have to be all by themselves, at least one of them, okay, if you have more than one. This one is by itself, so now to get rid of it, you do the opposite, which is square it. But if I square this side, I also have to square this side. So when I do that, this cancels with that, and I'm left with 2x plus 3 is equal to 25. I'm going to subtract 3, and I get 2x is equal to 22. Divide by 2, and x equals 11. Now, these you have to check. You must check. Now, 37 look like this. So I'm going to take my 11. I'm going to store it under x. Okay. And I am going to check right here. Second square root of 2x plus 3. It should give me 5 when I hit enter. And it does. You have to check these, because otherwise it could end up to be no solution. Okay, so that one checks. That's good. This one right here, I already have my radical all by itself. The square root is by itself. So what I'm going to do is I'm going to get rid of that by squaring it. Now be careful. If I square that, I must also square this side. It was like this. Okay, that's how the problem read. So you have to square that whole side as well. Okay. I don't know why I did that blue. Okay, this is how it read. If I'm going to square this side, I'm going to square this side. Same thing, just different color pen. Now, squares and square roots cancel each other out, so I'm left with 5x plus 1 right here. This here is the same as x plus 1 times x plus 1. When you do FOIL, or if you do the shortcut, you'll get x squared plus 2x plus 1. X squared, 1x plus 1x is 2x, and 1 times 1 is 1. All right, because it's an x squared, we have to get it set equal to 0. So I'm going to take the 5x over there by subtracting it. And I'm also going to take the 1 over here by subtracting it. That's going to cancel, so is that. Okay. Over here, I have 0, because that's what I was trying to do. And over here, I have x squared minus 3x. Okay. This is where some of you have trouble, because we talked about this after Chapter 10 test. You factor this, or use quadratic if you want to. I get x. It's just that your c is going to be 0. Okay, not that it's a problem. I'm going to factor out an x, and I get x minus 3. This is actually maybe something really similar to the one on your test. because a lot of you just came up with 3. But remember, you have 2 factors here. This is a factor, and so is this. You set each factor equal to 0. So you had x equals 0, and you have x minus 3 equals 0. Now you add 3, and you get x is equal to 3. So you just didn't have to do any work here. So one of your answers you came up with 0, the other one you came up with 3. Okay? Because again, if I took 0 right here, 0 squared minus 3 times 0 gives me 0. So you have to have that one as well. Now the thing is we need to check to make sure it works, both of them. This was your problem right here, okay? So wherever we see x, we're going to first plug in a 0 here and a 0 here. So this side gives me 1, right? Because 0 plus 1 gives us 1. So this has to give us 1. So 0 store x, second square root, 5 times x plus 1. Well, that gives me, that's going to give me 0, right? Square root of 1 is 1. 0 plus 1 is 1. And it gives me 1. Okay, so that worked. We also have to check the 3. Okay, when we plug in 3, when we check it, we're going to get 5 times 3, which is 15 plus 1. That gives me a square root of 16. Okay, when I plug in 3 here, I get 3 plus 1. That side gives me 4. Well, square root of 16 is 4. The left equaled the right. So they both checked. So both of them will work. Okay. But you can still check your answer. You can say 3 store x. You can plug this into your calculator and this side in your calculator, and they should equal each other. Second square root, 5x plus 1. Oops. Let's try that again. Okay. You get that? When I plug this into my calculator, x plus 1. See how the left equal the right? Okay. Now, that is all the solving ones. And I am going to take a break. I will do the rest tomorrow.